All right, so again, we are on linear programming. All right, so you can welcome back to our afternoon session, I should say. So again, we're on CSEC linear programming. All right. So we'll continue where I would have left off. So that question that I would have illustrated to everyone, that's the one that we're looking at. Let me get that up for you all. All right. So this was the practice question that we left with, and we want to complete this. So everyone is hearing me, right? If you can hear me, you can just say yes in the chat and so on and so forth, as well as the school that you're coming from or you're currently attending, I should say.
Yes, sir.
Nice. All right, so we want to write the set of three inequalities which describe the shaded region. So I know that I think it was Khadija Mackenzie had said something about feasibility region, even though we're not at that point yet, but it's good to highlight it somewhat early. All right, so we want to identify the three inequalities. So let us start with, so we have the shaded region, which is GHK. So let's start with the line x equals 6. What inequality? We're using that line x equals 6 as a reference. So what inequality does that show? Or does that speak to?
X is greater than or equal to 6.
X is greater than? You sure about that one? You can turn on your I think that's
X is equal to 6.
All right, that's the line, remember.
It's less.
I'm hearing a bit of feedback.
Yeah.
So, all right, sorry. Yeah, sorry about that feedback. Josiah, I think it's Josiah. Right. Sorry about that. My ears was off. So again, we're using the line HK as our reference to show which inequality that we're making reference to. Again, look at the shaded region. Just like when we said, okay, is this greater than or equal to, or is this less than or equal to? Jackson, go ahead. Jackson.
Sir, it's less than or equal to?
All right, how do you know that it's less than or equal to?
Because it's going to the left. Sir, because it's going
Towards the left. Left.
Going to the left, right? So remember, it's a shaded region. Remember that we're looking at the shaded region. So we want to highlight that as well. So it's to the left of the reference line. So to represent that inequality, it would be x is indeed less than or equal to 6. All right, what about the line? We're using the line GH as a reference. All right. Again, we're using GH, line GH as a reference. How or what would we represent that inequality by? Remember, we have y equal 1, 6x added to 5. That's the equation of the line. Remember that we're speaking about the inequalities. So what would be that inequality? Jackson, is your hand still raised? Oh, I guess so. Go ahead. I'm not seeing anything in the chat. Okay, oh, it wasn't raised. All right. Does anybody have any other input or want to say something? You can raise your hand or you can type it in the chat. So what inequality would we use to represent the shaded region that we're making in reference to the line GH? Anyone? Repeat that one. Can't hear properly. Oh, you're saying that it's somebody, sorry. You're saying that it's less than or equal to? One person is saying that. Anyone else? No? Anything?
Yes,
So remember that, oh, sorry. Remember that this is our shaded region. This is our shaded region, right?
less than or equal to.
Less than or equal to. All right. How do you know that it's less than or equal to?
What was the question? Could you
Sir,
repeat it?
Oh, I was saying that we're finding the three inequalities. We found one already, right? Using the reference line of HK, which would have been the line x equals 6. So we got our inequalities from that. So we wanted to, so we got our inequality from that. So we got x is less than or equal to 6. Now for the line, the reference line that I'm using, which is now GH, which is y equal 1, 6, x plus 5, I am asking what inequality would be represented by the part that is shaded using that as our reference line or equation. So I notice everyone had said that it's less than or equal to. All right. So what about the other line that I'm making reference to, which is now GK? What would that inequality look like?
Greater than?
To the shade, all right? Greater
Greater
than or what?
Greater than or equal to.
All right,
It's not
cool.
dotted.
All right.
Well,
So everybody is understanding why or how we got those values.
I thought it was just greater than.
No,
No, sir. No, sir.
no, not in that scenario. All right. And so can somebody tell me why it's not greater than?
Because
sir, the line, I mean, the shaded portion is above the line.
no, not that.
Not necessarily.
The line is a solid line, not a broken line.
Ox greater than.
All right. So let's see. Based on what you guys would have said earlier, those would have been the answers which most of us actually said. And if we had any issues with that, it would have been highlighted by your fellow students or classmates if needs be. All right. So that is the first aspect of it. Now let's move on to what we call activity 1. So John is currently on the overseas farm program, like especially in Canada, I would believe. His job is to pick apples and pears. Now, John finds he can pick no more than 20 kilograms of apples or no more, where is this thing? Or no more than 16 kilograms of pears in a day. However, he is not allowed to pick more than 30 kilograms of fruits in total, and I would believe it's on a given day. The other thing, or the other bit of information that we have is that he is paid $3 for each kilogram of apples and $5 USD for each kilogram of pears. We want to help John to determine how many kilograms of apples and pears he will need to pick to earn a maximum wage. Now, it's a lot to digest if you want to say that word or use that word. But we'll be taking it in pieces and we'll be deciphering it in pieces. So John finds he can pick no more than 20 kilograms of apples. So we know that we're picking apples and pears, I would believe. And we have some terms or phrases that we can use to describe the inequalities or the inequality symbols that we'll be using. What are some of the terms or words that we are seeing that we could use for the other slides or so, that we could use as it pertains to an inequality symbol? What are some of the phrases that come to you or speak to you in this scenario? Anyone?
Sure, John finds that he can pick no more than 20 kilograms of apples.
All right. Just like a phrase, like 2 words or so, right? So what 2 words from that can you get an inequality from, or even 3 words?
Sure, so x is
no more than
less than or equal to 20.
X is less than or equal So,
All right, no more than. So that's what I wanted to hear. But thanks regardless. What about is there anything else that would depict any inequality symbol that I could use? Any
no
other
more
phrase?
than.
Yeah, we said
Sir,
no more
and
than.
more than. More
And we,
than.
all right, and more than. All right. Well, he's not allowed to pick more than 30 kilograms of fruits. All right. Anything else in this scenario that we're given that could help us in the near future to answer any questions that we have? Anything else? Anything else that stands out to you based on this scenario, I should say? Nothing else? Anything else comes to you? Not necessarily an inequality symbol, but anything speaks to you a bit more. Oh, maximum. Maximum what? Shanoya, I should believe. Maximum what? Okay, maximum wage. So remember, at the end of it, we want to find how much is the maximum wage. And we'll be looking at we'll be graphing this a bit soon. But let's talk about what is linear programming. Can anybody actually give me a little definition of what they think linear programming is? Or why were you actually using linear programming? Why do we actually use linear programming? Do you think it is crucial, and in what sector or what business? Or give me an example, or give me your own thoughts on that. And remember to raise your hand. And you can type in the chat. What do you think, or why do we use linear programming? Anyone? No one yet? All right, to find the
Sir, I didn't hear that question.
Wait. So Davis had said to find the cost or profit of items. That sounds more like, even though that sounds more like consumer arithmetics, costs and profits, but it leads into some way that we'll see later. All right, linear programming, Moya. Thanks for that, Davis. Linear programming is to find the maximum or minimum value of a function. All right. How can we be more practical with it though? Why do you think we use linear programming? And who uses it? All right, to find the value of a statement or a functional problem. Oh, you're using the functional or functions. All right. Anyone else? No?
Who uses it? An accountant?
All right, accountants. Okay, businesses use it, right? So Khadija Mackenzie is saying, thanks for that, by the way. Linear programming is a technique, I believe, that is used in mathematics to solve problems involving maximizing and minimizing linear functions when several constraints are to be considered. All right. Linear programming generates the best possible solution. All right, some nice or lovely little answers coming in that I have to stop and actually look at them thoroughly. So this is why we think that linear programming is important. So linear programming, or what we call optimization, it shows how mathematics is used in your real life for decision making, right? So whether if you actually can do this manually, or you input it into a computer and then you can get the data and it gives you an output in order to test as Khadija Mackenzie would have said, the maximum or minimizing or solving problems in mathematics, given constraints. And as I think, I don't remember the individual's name, but they would have said that accountants. So linear programming helps businesses or corporations manage overheads, their inventory, and staff to gain maximum profits and to minimize costs. So when most business in the world or so, they want to maximize on their profits and to minimize on their overhead costs, like compensation, lights, etc., all that, right? So they want to cut short certain things in order to maximize their gains for the staff and actually for themselves. All right. Are there any questions on that? And thanks again, everyone, for the input that you have given and liabilities. All right. So that's more accounting, but yeah, assets and liabilities. All right. Is that clear so far? Are we
Yes, sir.
seeing? All right, cool, nice. All right. So what? Good. So what are some real life situations in which we need to create our objectives or our goals? Right? So,
Money.
oh, money. Okay. All right. So what would be your goal in a certain situation? So we have some situations or scenarios. Well, we have three of them. And we'll be going through those scenarios to show you how and why linear programming is so important in maximizing or minimizing one's business or corporation. All right. So let's start. So we have some objective-based situations. So we have an appliance within a budget of $50,000. So that's one real world scenario, real life scenario. You go somewhere, you have a budget. Before you even go somewhere, you have a budget as it pertains to what you want to spend on, whether it's an appliance, a phone, especially phones, computers, laptops, MacBooks, etc. Or you have a proposal, a project proposal. Your teacher gives you a project, it's due within a certain time frame. It says completing within 15 days. You're at university, when you go to university or colleges, or even sixth form, they give you projects and all of that you need to complete in a certain time period. Not necessarily homework, but you get at least 15 days to complete this proposal. Another thing would be businesses, well, quantities and the months. So if you're into appliances, shoes, etc., that a business might sell, you're a sales agent or you're somebody in sales and you want to meet the sales target within a month. So let's say the sales target is set, you need to get all of those sales or even higher in that period of time, give or take. Now, from these three real life scenarios or situations or objective-based situations, for the first one, we want to say what is the main objective to be achieved in each situation. So for the first one of buying an appliance within a budget of 50,000, what is the main objective to be achieved in this situation? What do you guys think? You can type in the chat or you can raise your hand. Do not just turn on your mics and speak. That's very rude. So what is the main objective to be achieved in buying an appliance within a budget of 50,000? What comes to your minds? Or your mind, I should say. Anyone? So you want to find out what is the main objective to be achieved when you're buying appliance. Wait. Buying an appliance within a budget of 50,000. Did you raise your hand? No. Okay. Jackson, go ahead. Go ahead, Jackson.
Sir, the main objective will be to complete within 15 days.
Wait. You heard what I said. This is what I said. Listen. For the buying the appliance within a budget of 50,000, what is your main objective?
To meet
Yeah.
sales.
They get a
To meet sales for at least.
Oh, again, wait. Again, you are not raising your hands. You're just speaking out a turn, which is not very good. All right? Raise your hand, and one of my colleagues or myself will address you. You can't just speak like that. But before Jackson, I would allow you to speak before I go to Josiah, right? So again, Jackson, what is the main objective in buying the appliance within a budget of 50,000? What comes to your mind? And Shania would have said in the chat, decide how you will come across the sum of 50,000. Jackson, before I go over to Josiah, go ahead.
Sir, the main objective will be to purchase an appliance within the range of $50,000.
Okay, all right. Josiah,
Less than or equal to.
Oh, you're saying less than or equal to, all right. Josiah, go ahead. That's nice to know. Josiah?
I would say what to aim for an appliance for 1 month to get it to be at least $50,000 to get
Alright.
that appliance.
All right, let's see. So we can say that we want to minimize the costs, right? So we want to minimize the cost. So as everybody would have said, we want it to be within the 50,000 margin, in the 50,000 range, right? Well, equal to 50,000 or less. All right, the other one. What is the main, Josiah? Can you lower your hand for me, please? All right. So for the second one, you want to complete the project proposal in 15 days. What is your main objective to be achieved in that situation? You can type in the chat or you can raise your hand and I will address you. Raise your hand. Do not just open your mics. So to complete within 15 days, what would be our main objective? All right, Alicia. Oh yeah, you can see.
Yes, sir. Alicia, like, sir, complete it within 15 days or less.
So what are you actually doing? Are you maximizing? Are you minimizing? So far, I've been using minimize. So minimize the cost.
Minimize.
What are you minimizing?
The completion within the 15 days.
All right. So what is that 15 days normally called? What do we normally associate with the term days, months, years, etc.? Minimize what exactly? I'm trying to get something out of you, but yeah. Minimize what exactly? You said the 15 days, yeah, but what term can I use to represent that 15 days? Duration, all right. There's another word for duration, but that's fine. All right, time. Minimize the time. Thank you. And you can lower your hands, Jackson, and the other person that has their hand raised. Thank you very much. So you want to minimize the time. Now, what about the third option? Well, not the third option, but the third thing, which is meet the sales target within a month. What would that be now? Yeah, the deadline. What else? All right, what are you maximizing, Shania? All right, you're maximizing the sales before the deadline. But what else am I missing? I'm maximizing the sale, yeah. What else? Is there something else I should add to that? Engagement, all right. So what else could I say about the meet the sales target within a month? I want to maximize the sales, but what? What did they give you? What did it say, or what is the question? Well, profits. All right. So when you maximize sales, you're actually, you can say maximizing profits. Josiah, go ahead. Efficiently, all right. Maximizing profits, sales, etc. But something else is missing. Josiah, you can go ahead, if I'm pronouncing that right.
Oh, you want to maximize the amount of profit that you get.
And what else? What else? Something else is missing. It says meet the sales target within a month. Which one?
Also, the sales target. The amount of sales.
All right, but remember, this goes for everyone. You can lower your hand, Josiah. Thanks much. So it says meet the sales. All right, fantastic. Finally. So maximum sales target before the given time. So you're trying to maximize on your sale while or within the minimum time that is given, because they give you a time, which is a month. They never said, okay, you can take however long you want. No company will tell you that, right? They won't earn any money from that. You won't get any money from that. All right. So those are the main objective from those functions. All right. Now, when we have this, what do you call it? When we have the same situations, we have limiting factors, what we call constraints. So again, for the first one, when you're buying an appliance within a budget of 50,000, what is your constraint? What is your limiting factor for buying a appliance within a budget of 50,000? What is your constraint? What is your What is your limiting factor for the first situation that you have on the screen? Anyone? Any takers? None? What is your limiting factor or your constraints for when you buy an appliance within a budget of $50,000? All right. You're thinking? All right. Yeah, try not to go over budget. So your predetermined budget of 50,000. So you would have determined that budget beforehand, and you don't want to go over that, right? What about the complete within 15 days? What would be your limiting factor or your constraints? Can't waste any time. All right, so your time. So I'm getting that in the chat. So you have a time limit of the 15 days, right? All right, what about the third one? So you can lower your hand, Josiah and company, if your hand is still up. What about the third one? When you're meeting a sales target within a month, what are your limiting factors or your constraints? All right, I would believe that's limiting time. All right. What else? Well, that's most of it. Josiah, you can go ahead quickly.
Have the limited duration.
All right, limited duration or time. And remember, your predetermined sales target, whatever that target is. Yes, try, as Shahara would have said, if I would have said that properly, try to increase your sales before time. All right, Josiah and company can lower your hands. All right. So those are some of the limiting factors and the main objective that we can get from that. Now, let us talk about optimization problems in mathematics. Now, we would have said earlier that we have found some of them already. You would have said that maximizing profits, minimizing time, even though the cost wasn't there, but you can minimize costs. So for minimizing time as students, you will want to maximize on your free time to study. Some of us might play games during that time when we have free time or we just want to chill, but they always tend to tell you to study when you can, when you have free time, especially when you have free time. So, and the other thing would be to minimize costs and minimize the use of resources. Now, what do you think is the aim of optimization problems? What do you think the aim is? I know that some persons would have mentioned it earlier in their definition for linear programming, but I'm asking you right now, what could your aim of optimization problems be? What are you actually doing?
To make a decision.
All right, make a decision based on what? All right, somebody's in the chat. Based on what? All right. Based on what? Make a decision based on what? What are you making the decisions on? Nobody? All right. Based on the information given, what information? What? I just used some words, well, terms not too long ago. Real life scenarios, all right. So, one more. Let's see if I get one more in the chat. Or anybody wants to speak, raise your hand and I'll address you. All right, not getting, oh, to find the maximum minimum value of a function. That sounds like coordinate geometry, still-ish. So the aim of the optimization problems is for us to find an optimal solution, being that or barring that we have constraints of the problem, right? So we have some limiting factors or constraints that will be given, and our job is to find out what is the optimal solution. So that is our aim for the optimization problems, all right? So all of these problems, maximizing profit, minimizing time, minimizing cost, minimizing the use of resources, we want to find the optimal solution based on our constraints that we're going to face. Now, let's go back to the activity that we would have shared with apples and pears. Now, we want to go about writing or making some using the same thing that we just would have mentioned, which would have been constraints. So do we have any constraints in this scenario, in the second, what's this? The third sentence or second paragraph? Do we have any constraints? John finds he can pick no more than 20 kilograms of apples or no more than 16 kilograms of pears in a day. However, he is not allowed to pick more than 30 kilograms of fruits in total. Do we have any constraints? Do we have any limiting factors based on
Yes.
this real world or real life scenario? All right, give me one constraint. Only one, the person who's speaking, even though you never raised your hand, I think.
Shanoy said yes in the chat, sir.
Okay. All right, Shanoy, you can give me one while the person who just spoke, the young lad that just spoke, you can give me one constraint that you're seeing, and Shanoy will give me another one, and then let's see if we have any more. Go ahead.
Shanoy typed in the chat is not allowed to pick more than 30 kilograms of fruit.
All right, good. And the young man who was speaking, I guess he's shy right now. Well, let's see. So we have apples and pears, right? So we need to identify and represent these constraints algebraically. So we have it in words, as you would have seen earlier. Now it's for us to decipher these into algebra or algebraic statements. So we need to assign some variables, as you may recognize them. So I am using let x. Generally, they tend to tell you what x is. If not, then you'll have to use your own thingy. But normally we use x and y because those are on the graph. But we can use different things, but for our thing right now, we're using x and y. So x represents the kilograms of apples to be picked, or the number of kilograms of apples to be picked, I should say. So what would y represent? Can anybody give me what y would represent? I already gave x, so what would y represent? All right, pears. What about pears? What about pears? What about pears?
The amount of pears.
The amount of?
Pears.
The number, you can say the number of kilograms of pears to be picked. All right?
Yes,
all right.
sir.
You can't just say pears, right? You have to literally say what it actually represents. All right? So what are these x and y's called? I would have said it earlier. Let's see if anyone was actually listening. X, y, what are those?
Variables.
Variables. All right. Now we have some constraints based on the question that we would have, the activity one that we would have seen. Now, do you think, or should I say, the number of kilograms of apples that John needs to pick, how would I represent that as an inequality? The number of kilograms of apples that John needs to pick. How would I represent that as an inequality?
Sir, can I go back to the question, please?
Oh, you want, okay. That's the question. You got it? Take a screenshot. Take a picture. You got it?
Yes, sir.
All right, thanks. All right, so those are variables. So again, how would I represent the number of kilograms of apples that John needs to pick? All right, I'm getting some answers, which is fine. But there is something, I never gave any actual numbers or digits. I never gave any digits in that scenario. I just said the number of kilograms of apples can John pick. X equal Y, you sure about that? X equal Y, so you're saying that the number of kilograms of apples is equal to the number of kilograms of pears, Mr. Davis? That's what you're saying? All right, Josiah, go ahead.
I said the same thing about x is equal to y.
All right, let's see. Shania, go ahead. Thanks. Shania, yeah. Oh, yes.
Sir, you hear me?
Yeah, I can hear you.
So X is less than or equal to 20
All
kilograms.
right, but did I actually say, okay, did I say he cannot pick more than 20 kilograms of apples? Did I say that? What did I say? I said I have an inequality to represent, which is the number of kilograms of apples that John picks. How would I represent that as an inequality? I never said anything about 20 yet, you know. I'm just asking a question. So most persons are saying that X is less than or equal to Y. All right. So lesser than or equal to what, Shanoya? So in essence, should John actually pick 0 kilograms of apples or at least 0 kilograms of apples? Which one do you think?
At least.
All right.
At least.
So I'm asking you guys now, boys and girls, sorry. How would I represent that as an inequality?
X is less than or equal to Y.
But wait, but can the amount of that, well, can the number of apples that he picks, can it be a negative number?
No, sir.
All right, so where should my X value start from using my inequality? There is no Y because Y represents pairs. We're not talking about pairs, we're talking about the apples only. So 0.
Sheldon Miller has some feedback, sir.
All right.
Sheldon Miller is saying X is greater than or equal to 0.
All right. So Sheldon, you want to speak on that for me, please? You can open your mic, Sheldon Miller.
Yes.
Yes. How did you get that X is greater than or equal to 0?
Let me add something. Sir, you said the least amount is 0.
Yeah. Because there's no negative, I can't pick negative apples, I can't pick negative pears, right?
Yes, sir.
So you're saying that that is why you would have said X is greater than or equal to 0. Greater than or equal to 0, right?
Yes,
All
sir.
right. All right, thanks much. Now, what about this inequality that everyone was speaking about earlier? He cannot pick, no, this is what is statement. He cannot pick more than 20 kilograms of apples. How would I represent that one?
So it would be Y it will be X is less than or equal to 20.
X? Did you say X? Repeat that one for me, Josiah.
X is less than or equal to 20.
All right, Shanoya, thanks much. Shanoya, do you want to speak? Thanks, Moya, in the chat.
Sure, I agree.
Yeah, I agree. And Moya, I would have believed that you agree too. And does everybody else agree that X is less than or equal to 20? And again, what indicates that you're using the less than or equal to symbol? What phrase indicates that?
More than.
All right, and it says he
More
cannot pick more than, right? So that's one inequality, and that's 2 inequalities. Now let's look at the other one. The number of kilograms of pears he picks. Again, you want to say to yourself, could I pick negative pears or negative values of pears? Could I do that? What would that inequality look like? That would represent the number of kilograms of pears he picks. What would I write right there? You can't just say more
Y
than.
is greater than.
You have to write the variable.
Greater than or equal to 0.
Repeat.
Y is greater than or equal to 0.
All right, thanks. Shanoya, go ahead. And remember to raise your hand. Just don't.
Sure, I agree.
You agree too. All right. I guess everybody's agreeing. I see 3 persons, and Kenny would have said, even though his name is not Kenny, but I think somebody would have said Kenny earlier, yesterday. All right, so that's our 3rd inequality that you would have gotten. All right, what about this one? He cannot pick more than 16 kilograms of pears. Shanoya, go ahead. Shanoya only. Go ahead.
Sir, Y is lesser than or equal to 16 kilograms.
All right, thanks much. Anybody else? You can lower your hands, please. Thanks much. Anybody else would like to make a note? Do they agree, disagree? Is that correct, that what she just said? What did she say? All right, Moya, Okay, all right. Y is less than or equal to 16. So I've gotten 3 responses indicating that it's right. Anybody else would like to interject? All right, that's code for go ahead. All right, all right. And the last constraint, he cannot fit more than 30 kilograms combined. How would we write that one? You can
Sir, X.
raise your hand and then we'll address you. Go ahead, Shanoya. Go ahead.
Sir, XY is less than equal to
XY,
30.
XY. Forget XY. You know, when you say XY,
Yeah,
that's
because I two
like
of
it's
them.
multiplied. But that sounds like it's multiplied. I never knew I could multiply apples well.
Sir, X plus Y then?
All right. Why would you now say that X plus Y?
Because it's
X
combined.
plus Y.
Combine. So the word combine indicates that, right?
Yeah.
All right. Who is that speaking? Is that Moya or Shanoya? All right. Moya? Oh, you
Yes,
can go
sir.
ahead. Oh, Moya, you can go ahead. Your hand was raised.
Yes, sir. X plus Y lesser than or equal to 30.
All right. And I'm seeing in the chat that multiple persons would have said that besides Mr. Is that Mr. or Miss Williams? You'd have said X plus Y is greater than, no, sorry, less than 30. So why are you using the less than sign? Williams, you can go ahead. Is that Tolit? I'm poor on pronunciations, my bad. Josiah, you can put on your hand, Josiah. Williams. Should we get that person to open their mic, or why do they have less than 30 kilograms? Was that a typo? Do you actually mean to say something else? All right, I guess I'm not getting anything from that individual. So X plus Y is less than or equal to 30 kilograms. Now, how many inequalities are you seeing on the screen right now? How many inequalities are we seeing on the screen right now?
5.
All right. Now, let's go back. Let's go back a bit. Did you see 5 inequalities from this statement? From the activity
No,
that you're
sir.
seeing? Do you see 5?
No, sir. No, sir.
All right. So where did the other 2 come from? What are the other 2? Why do I have them there? Where did the other 2 come from?
Sir, the other 2 was, the X lesser or equal to.
Well, greater. It's greater.
It's greater.
Yeah. Greater than or equal to. So I'm saying, why do I have these 2, right? These 2. So this one, this inequality and the word statement, and this one right here. It was not given, so why do I have it? I would have said this at least 2 times. Why I actually placed it in the bunch of inequalities. All right, so it shows that you can't go below 0. In other words, it's a negative. You don't have negative apples. You don't have negative kilograms of apples. You don't have negative number of pears, right? So that is why. So as you should be able to see that it's not necessarily explicitly said, as in said in the statement, but we should know that when we're dealing with things of this magnitude, which are objects like pears and apples, they cannot go past the 0 mark, right? It's either you have 0 kilograms of apples or you have more than that, all right? You can't have negative, okay? So when you read the questions, you want to keep that in mind. Understood?
Yes, sir. Can I go back to the question, please?
Oh, everybody wants a question. All right, give me a sec. All right, that's a question. Ready?
Remember to put in the money part, sir, so they can just take a screenshot once.
Oh, there it is. So this is all of the question, because we'll be looking at the money aspect as well. Can I continue?
Yes, sir.
Yes, sir. You can
All right,
go
good, fantastic. All right. Now, what is the problem that we're solving? So based on the screenshots that you took, and let me just go back to the question, what are we actually solving for? So that's the question in its entirety. So what are we actually finding?
How many kilograms of apples and pears should you need to pick to earn a maximum profit, maximum wage?
Yes, so you want to find his maximum wage. So the problem that is to be solved is that you need to find his maximum wage, right? Because remember, he would have been paid this amount of US dollars to pick each kilogram of apples and each kilograms of pears, represented by $3 and $5 respectively. So in order to determine how many kilograms of apples and pears John needs to pick to earn a maximum wage, you can say that he's working on, as they would have said or highlighted in the question, he's working overseas on a farm, right? So you want to see, oh, okay, how much do I actually need to pick to get the maximum amount of money each day, right? All right, good, Maria and company. All right, so that's the maximum wage. Now, how would I represent that maximum wage as an equation? What values should I be using? Okay, and you say, oh, you just fancy and put money. You said 3x added to 5y is equal to money. All right, but what is 3x plus 5y equal to? It's not just money, but it's whatever the person would have said, which is the wage, right? Does everybody agree or disagree? Does anybody agree or disagree with the equation that Moya would have sent in the chat? 3x added to 5y. All right. All right. So again, why am I using 3 multiplied by x? Why am I not using 5 multiplied by x? Tell me why. Why am I not saying that 3 is going to be multiplied? We should be 5 multiplied by x. Why is it 3 multiplied by x? Anybody?
Because X represents apple.
All right, x represents apples, each kilogram of apples, etc., or the number of apples, I should say, the number of kilograms of apples. And the 3 represents the US dollars that you get, right? So this is why we have 3 being multiplied by the variable of x added to, because it's a combined thing, and it will be 5 multiplied by the variable y. All right, so that is equal to our wage.
Sorry, sir, if I may, don't want to take time because I know I see someone typed in the chat 3 equal 1 kilogram of apples. So you have to be careful of how you're looking at the variables and what they represent and what the numbers are telling you. So the 3 is the amount of money he gets for picking 1 kilogram. So the 3 is money, not the 1 kilogram of apple. Just to make sure you're clear and precise on what you're saying.
All right, so you have one to the $sign and $sign USD and that Shanoya. All right. So now we're gonna plot those inequalities that we had. So we have 5 inequalities to plot. So we need to look at the screen very carefully and the different colors that indicates the lines that we're gonna use. All right. So let's say my first inequality. All right, that purple line right there. Oh, and remember your graph paper. I totally forgot about the graph paper. Remember to plot this on your graph paper, not just taking a screenshot or a picture of this. You want to actually plot it for yourself and to see if you're going to get our values that you're seeing on the screen. So you can say this looks like 1 centimeter to 5 units on both axes. So that's something to note as well. So 1 centimeter to 5 units on both the X and the Y axis. All right. So I'm going to give you at least 45 seconds to get that graph paper, or graph book, your pencil, your ruler, eraser, sharpener, etc. Well, which you should have had already, but just in case you forgot the graph papers, you have 38 seconds remaining. All right. So I guess you should have all of those information already. Well, materials, I should say. All right. Is that purple? Because I am colorblind. Men are colorblind. So that color that you see, that's either purple or pink. Can somebody remind me what color that is? Anyone in the chat? Okay, that's really,
Purple.
I must really hate purple. But anyways, purple. So let's go. So that purple line, what would that value be? What would I write for that? Would I write an inequality or would I write an equation? So are you writing an inequality or an equation to represent the line, the purple line that you're seeing on your screen right now? Which one? So you want to answer that first, then let's see what you get for your actual value. So go ahead, anyone. You can open your mic when you raise your hand after we have addressed you, or you can type it in the chat. So is it an actual line, an equation of a line, or is it an inequality? What is it?
The equation of a line is y equals mx plus c.
All right, so it's an equation of a line, first of all. So what is this actual line though? What does this purple line represents for the equation of a line that you're seeing? What is this equation? Not the equation, not the general formula, which is y equals mx plus c, but what does this line, purple line, represent? What is that value? What is the line equal to? No one? No takers?
Nothing in the chat yet.
Oh,
I see a
somebody
y
said
equals 0.
All right. Why do you say y equals 0? And I see a x equals 0.
And I see a kilogram of pairs. Careful of the kilogram of pair. Think about that one a little bit more.
Can you explain yourselves, McCarthy and Manika? Remember, you're using variables right here. So it's either using x or y. So the two persons, McCarthy, can you explain why do you have x equals 0? And Lucia, can you explain why you have y equals 0? You can open your mic for me, please, the two individuals. Nothing? Okay. Does
Maybe
anybody...
they can type. If they can type quickly, they can do it in the interest of time.
Tough crowd.
So you could find out from Damien what he meant by kilogram of pair, please.
Yeah, Damien could speak. You call his name, so he should be aware. The purple line is a vertical. So McCarthy, you're saying the x equals 0. The purple line is a vertical on the x-axis, so it's x value, which is 0. Luke, who's the next individual? It was a girl. Can you explain why you got that? Damien, likewise, why are you saying kilogram of pair? What's your thought process?
I said that because the line, the push part is 0 there. And basically, it has said it would be anything above 0, like 0 and above.
Above 0 on which axis?
On the y-axis.
All right, you're saying that. But remember, oh, can I use this? So if I have, when I'm drawing, let's say I have a line right here. Okay? Let's say it's at the 15. What would that line be? What's her name? Luisha? Sorry. I'm horrible. What would that line be? Let me draw it a bit better. I drew a line through this coordinate. Well, not coordinate, but this point. What is this equal to? Go ahead.
It would be 15.
What is 15? Is it y, x, what?
Oh, the x would be 15.
x is equal to 15, right? Now,
Yeah.
what if we did this? Put this part right here. What would that be now?
The y would have been
Y equal how much?
15.
All right, so as you can see on the screen, so McCarthy would have been right, so that would have been x is equal to 0, right? So, Luisha, you would have seen your error. You see how you could have corrected yourself?
Yes.
All right, good. All right, cool. Let's continue. Is everybody seeing that though? Is everybody seeing why it's x equals 0? That this line is x equals 0. The purple line.
The first line here.
Okay, all right, cool. All right, remember, close your mics. Let's continue. Let's look at the other color that we're using. All right, that blue line, what does that represent as? Is that an inequality or is it an equation? Repeat.
Equation.
Okay, so what is the equation? All right, Shania had said x equal 20. Anybody has any other input? Do you believe that is right? Do you believe that is wrong? Do you believe there's something different about that question? Is it x equal 20? Are we all agreeing with Shania? Yes? No? Why not? All right, I've seen 2 responses so far. Silence is a yes. That's what I say too in my head. So x is equal to 20. So that's x equal 20. All right. All right, the other line. What color is that? The one at the bottom. What color is that, everyone? I don't like saying colors. The only color I know are simple colors. Red. So what color is that? The one at the bottom?
Indigo. Indigo. Indigo.
No?
One at the bottom.
Purple. Purple for people. Purple.
Yeah, it looks like
Indigo slash
dark purple. All right, dark purple. Well, the first one looked like pink to me, so dark purple. Let's go with dark purple. Dark purple, everyone. So what does that represent? All right, I'm seeing y equals 0, McCarthy. Anyone else?
Y equals 0.
All right. All right. So again, once you see the actual lines, it would be the equations, right? So this is why I always ask if it's an equation or inequality. And you'll see why, or when we do the inequality aspect, you'll see which aspect is actually important. We were doing it before, so let's see. All right, where's the other line? So it's y equals 0. All right, the green line. What is the green line?
Sir, would that be y equal 15?
15. And remember, make sure you're drawing these things, you know. Make sure you're drawing them. As in, you're actually plotting these things on your graphs. These lines on your graph, okay? All right, so y equals 16. My bad. Okay, I understand. So you always want to make sure you're interpreting the graph correctly. If you do physics, you would know that it's quite important when you're doing the graphs, the intervals and all of those things. All right. All right, everybody's saying y equals 16. So let's do the reveal. Y is equal to 16. All right, next. So how many how many lines or equations of a line have we plotted so far? How many?
4.
And how many inequalities should we have?
5.
Remember that this is not an inequality, these are the lines, all right? So we'd have 5. If we have 5 inequalities, we should have 5 lines, right? So we have 4 lines so far. So what is the 5th line? I want you to work that one for yourselves, and you'll tell me the where it should go, right? The last one. Can anybody remind me what that line is? What that line is equal to? Not the inequality, but the line. What is the equation of that line for the 5th one? For the 5th line, what is that equation?
Y equals
X plus
30.
Y. X plus Y. Continue.
Lesser than or equal to 30.
Remember, that's the inequality. So what is the equation? Remember, equation has a what?
Equal sign.
All right, so what is the
X plus
equation?
Y is equals to 30.
Right, done. Likewise, what Shania would have said and Moya in the chat. So x plus y is equal to 30. I want you all to plot that on your graph and to indicate or tell me where and how I should plot that on my graph. So I'm going to give you 90 seconds. That's more than enough time. So let's see what happens. Do not open your mics and shout out any answers. When I am ready, when I think that everybody's ready, I will address you. So in the meanwhile, you can type in the chat if needs be. Otherwise, do not open your mics as yet, unless you are told to do so. And I should not be repeating myself so many times. You should be able to follow the rules. Our rules are not meant to be broken right now. Another time, not this place. All right, you have 70 seconds, less than 70 seconds. Accuracy and precision. All right. I think I would have given more than enough time, to be honest. 90 seconds should not be that. It's not necessarily needed for this part. All right. So when you're plotting it, what are the values that you use? In other words, what are the coordinates that you use? Obviously, you can't just tell me to draw a line. You need to tell me where to draw that line. Where should I start at? What are my points that I'm using to draw that line? We would have done something like that earlier this morning. So it's up to you to apply that knowledge if you never had it before. Good for you, Miss Mackenzie, but right now I want coordinates. Thank you for the nice depiction. I want coordinates. Wallace, you would have gotten 30 on the X and 30 on the Y. Are you so sure? If X plus Y, Wallace, if X plus Y is equal to 30, if X is 30 and Y is 30, 30 added to 30 is 60. That is not the same thing as 30. So you want to make sure you have the correct coordinates. Now, because you think, do not think that 0 is not significant. In this case, it is significant. All right, so I'm getting some answers. I'm getting 30. Josiah, wait a bit. I'm getting 30. 30 on the X, Y is 0, corresponding value. X is 0, the corresponding Y value is 30. I've gotten that from 2 persons. Do you have anything else to say, Josiah? Speak. Are you going to speak?
It would have been 0, 30 on X and 0, 30 on the Y.
All right, good. What's that? Tarisha? How did you get? Oh,
hi, sir. I'm Jessera's mom. Jessera is physically challenged, so when you see her pressing the mic, that's what she can do. So I don't know if it's there any. Okay.
That's fine. That's fine, man.
All right. Sometimes. So when she's the pressure, she can't manage to go.
Understand.
Okay.
Thanks much. So, for this one, what was I saying? Oh, sorry. Yes. Does anybody have any other different points? I think somebody would have deleted their comment, Tarisha. You would have said 0, 0 on the X and 15 on the Y. I think you deleted it, so I don't know if you want to correct yourself. But do we all agree on that? The points that we have, the coordinates that we have so far? Do we all agree on that? Okay, I would have said silence is okay. All right, so that is what I would have had. And that would be, what would this line represent? The red line. What equation would that represent?
Sir, x plus y equals 30.
All right. Josiah, you have a question? I know I'm pronouncing it wrong, but I can't. Hello? No questions? All right. Oh, and you would have said x plus y equals 30. All right. Nice, nice, nice. Lovely, 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 lovely. Now, those were the lines. Now we need to actually get the inequalities. So, you guys, or well, I should say everyone, would have mentioned, let me give. All right, one of the inequalities would have been x is greater than 0. Where would I shade on that on this graph? The graph that you're drawing right now, or you drew, where would I shade x greater than 0? Where would that go? Where would I shade in order to show that inequality that x is greater than or equal to 0? Any takers? So the purple line, this purple line, I want to find out where the inequality is. Where should I shade? Should I shade to the left or should I shade to the right? All right. So you're saying to the right. All right. All right. What about the other inequality that we had? What was it? X was what? Can anybody remind me of the next inequality? X was what? All right. X is going to be less than or equal to 20. Now, where would I shade for that one? Which line would I be using to make as my reference point? What is my reference point? What line is my reference point in order to plot or shade, I should say, X is less than or equal to 20? You're saying pink? You sure about that pink one?
Blue.
All right, blue. All right, we're going to use blue. So you're saying shade to the left or the right? Which one is it? Left, right of the blue line?
Left.
All right. So if you notice now, I am going to the right for the x is greater than or equal to 0. And I'm also going in the, well, not also going, but I'm going to the left of this other line, which is the blue line. So if you notice now, you're getting this region right here so far, all of this region, right? That's what you'll be getting that would be highlighted. Why am I doing this? To show you that when you go to the right of the the purple line, the light purple, that is when x is going to be greater than or equal to 0, right? So everything over the right side of that light purple line. Then for the blue line, we're using that as our reference. And then to plot our shade, I should say, x is less than or equal to 20, it would be the left side. So what that means, what does that mean? When I shade my thing, really, it would be represented by all of this section that you see being shaded, right? And remember, we can't have negative number of kilograms of apples, right? So it's within that region right here. So x greater than or equal to 0 and x is less than or equal to 20 is within this shaded region right here, which should be light blue or something of that nature. I'm not sure what the color is, but yeah, it should be this aspect, right? Is everybody understanding that so far? That part. And it's very important to highlight the parts that we're shading because that represents the region that is our inequality. Is everybody okay with that?
Yes, sir.
All right.
Sir, could you go again?
All right. So when I go back, remember, we would have said to the right of this purple line, I wish I had the actual colors. So over here, all of this, even going further, right? This purple line that I'm drawing, that is for the inequality that x is greater than or equal to 0, right? You got that so far, the young lady that
Yes.
All right, cool. Now I'm going to use a different color. I'm going to look for a blue to represent x is less than or equal to 20. Now, x is less than or equal to 20. I use the blue line as my reference point from my equation of x equal 20. And they said I should go to the left. So if you notice now, I'm shading over here, right? So where the x is greater than or equal to 0 and where the x is less than or equal to 20, it's in one particular region, which is it's being boxed up right here that I'm highlighted in the blue line thing, right? So that's all I'm saying so far. So that's just 2 of the inequalities that we have shaded so far. And when we continue, you'd realize that there are more parts that are actually going to be shaded. So,
Okay, sir.
So this is how we get that little light color right there. It shows 2 inequalities. X is greater than or equal to 0 and x is less than or equal to 20 because those are where the regions, those are where their borders, right? So that's where they come together and meet, right?
Yes.
So we're going to the next inequality that I need. That inequality, I have x, what is it? Oh, sorry. I have the next one. Y is, what was it? Y is greater than 0 and y is less than 16. Where would that region be? Where would that region be bounded? So it says y is greater than 0. So I'm looking at this dark purple line. I'm looking above it. And then it says y is less than or equal, sorry, y is greater than or equal to 0. So I'm looking above that, right? This dark purple line. And then y is less than or equal to 16. I am looking below this green line. So where should I shade? All right, below the green line, Kino, where should I stop shading? Because remember, I do not have negative apples, number of kilograms of apples or pears. So where should I stop? You said below the green line, but where should I stop? Which color line should I stop at? When I say below the green line, then what other color should I stop at? I can't just continue going vaguely all over the place. So you said below the green line, but where should I stop? Kino, since you had said that below the green line. And anybody else that can assist? All right, the dark purple. All right, Shania, thanks much. So you are all working together to get to this fine answer. So we're shading below that, right? So you see the light blue on the left, the bottom part, you have the light pink. And if you look at it, you see the colors coming together at one location so far, right? So remember now, those are 4 inequalities. And how many inequalities should we have? We should have 5. So we need 1 more. Now that 1 more inequality, should it be above the line x plus y equal 30 or should it be below the line x plus y equal 30? Go ahead, tell me what you guys will tell me or get. So the last inequality, which region should I shade? Should I shade above or below the line x plus y equal 30?
Above.
Above.
All right, let's see. Well, let me write back the equation. Sorry, the inequality. X plus y, or is it less than or equal to 30? All right. So remember, we'd have gone through some things or strategies that we could have used to see if we're shading below or above the line in reference. So x plus y is less than or equal to 30. So for the persons who are saying above, why are you shading above? For the persons who are saying below, why are you shading below? Could you give me any reasons to why you're doing that?
Lucika, you can go ahead, sir. You are the first one to type in the chat below. Go ahead, Lucika.
You shade below because it less than or equal to 30. So
Yeah,
it
but
can go above, it can go above 30, so it must have to go below 30.
oh, you see that, everybody? She just said if it's less than or equal to 30, that means it can't pass 30. And that's very important for something that we will be doing or should be doing. But let's hope everybody remembers that part that she just mentioned. So she says that x plus y, if we're using that reference as equal to 30, it has to be, if we're writing it, if we're shading inequality, it would be below because it can't pass the 30. If it passes 30, that means it's above, or in other words, it's greater than. All right? So we'll be shading below. We'll be shading down here. And remember, we cannot have negative number of apples or a negative amount of number of kilograms of pears, okay? So that is why we are bounded by the regions right here that you're seeing on your screen, okay? So that's also something that you want to contemplate going forward, all right? So that little fading green section, all right, that's x plus y is less than or equal to 30. Now, we have plotted all of our inequalities, well, shaded the sections that would represent inequalities. Now, let's examine this region that is shaded. Do you notice anything about the region that would satisfy all 5 inequalities? Do you notice anything? The region that is going to be shaded that represents all 5 inequalities.
Yes, come out
Anyway? Okay, somebody's saying a right angle triangle. Are you sure that's a right angle triangle? You are looking at the entire thing, which is below R. I am looking for where everything is shaded, where they're overlapping. Every color, all of the colors are overlapping. Are you seeing anything? If you're not, we're gonna zoom in a bit. All right, let's see. So let me just run this back one more time for the colors. All right. So this, you might not be able to see so well, but this, all right, somebody said trapezium. Let's see. So the one that I just highlighted in red, that is for these 2 equations, which are inequalities, which are x is greater than or equal to 0, and x is less than or equal to 20, right? Everybody seeing that? Yes or no? Just tell me, yes or no? Is everybody seeing that? So the red?
Yes, sir.
Is that red? I'm not even sure right now. So it represents x is that and x is less than that. All right. So let's see. I'm going to use a different color to assist everyone a bit better. Okay, I'm going to use green. So green is going to be represented by 2 inequalities, which are y is greater than or equal to 0 and y is less than or equal to 16. Sorry for the fast writing. All right, so that's the green section, right? As in the section that is below the green and the purple, dark purple. So I'm going to highlight that in green. Now, is everybody seeing the 2 colors that I just have? Is that red and green? Everybody seeing where the red and green overlaps each other?
Yes, sir.
All right, so that is what, you're not seeing none of the colors? Well, you have to look at the YouTube back. Look at the YouTube. When this is done, you can look at finished. You can look at the YouTube because it should be there. But I'm just marking up the screen to show you where the thing should be. Next color. Which color should I use? I'm not even sure. Let me use this color, which is purple, I believe. So purple.
It's the light blue, sir.
Or light blue.
The light blue might stand against the red and the green.
Really? I am so color. Green. Which color said I should use?
The light blue, the one that's third from the right.
This one? This one?
Yeah, that one.
All right, so the blue indicates x, the inequality x plus y is less than or equal to 30. All right, and remember that we would have said that it's below the line. Yes, we're gonna go a bit, we're gonna zoom in, but I just wanted to highlight where all three colors are overlapping. The three colors that I use represents all 5 inequalities, right? Do you see that they're all 3 colors? Do you think they're overlapping at one particular place or all over the place? Which one is it? Are you all seeing that?
Yes, sir.
All right, so you've seen all 3 colors, the red, the green, and the blue in one particular place, right? One set place, right? So we're gonna zoom in a bit. I just did this to just make sure that everybody's on the same, everybody's seeing it. All right, trying to see it, right? So I'm gonna
Sir, could you just go over the boundary of that part that has all, oh, you took it out already. So maybe they could see the boundary of the region that covers all 3. Maybe
I'm
that
gonna zoom in. I'm gonna zoom in. All right. So this is the zoomed in aspect of it, right? So this little section that I would have shaded, which would have had the 3 colors that I used earlier, this is the region that they're overlapping, or all of them are basically in each other's way, right? So that is the region. Now, someone would have said a right angle. They were looking at the bigger picture, which is the red line. That's not what we're actually looking for, right? We're looking for where all of the inequalities are overlapping each other. So, in other words, we'll see it shortly, but these are feasible solutions. And why would it be a trapezoid? Trapezium, sorry. Moya, how much sides does a trapezium have? Or how many vertices does a trapezium have? You can always say that. So these are some feasible solutions. So anywhere along in this polygon would have Josiah, you can go ahead.
Yes, it's that easier because it has four vertices.
All right, let's see if it has actually 4. All right, so thanks for that. So we have the feasible solutions. So these are just 2 random points in the shaded region that we have that satisfies all 5 inequalities, right? Now, the shaded region is what we call our feasibility region. So again, when it satisfies all the inequalities that we have, which are all 5, not 2, not 3, all 5, right? That we are using based on this question. So how many vertices do we have? Josiah, you can go ahead if you have a question before that. Go ahead, Josiah. Yeah, favorite part. All right, Josiah. All right, cool. All right. So can anybody give me the vertices, the coordinates? Well, yeah, the vertices, the coordinates for the vertices. You
Sir,
can
one of them.
Yeah, let's continue.
Sir, one of them would be 2010.
2010, as in what and what axis? X and Y?
On the x-axis, 20.
All right, cool.
10.
All right, that's 1. So I got 1 so far, even though I can animate, I get all of them one time, but so you said 2010. Anybody else?
No.
All 5.
0 on the Y and 15 on the, sorry, 0 on the X and 15 on the Y.
All right, good. Anyone else? You can type in the chat as well.
20 on the X and 16 on the Y.
Repeat that one. Repeat that one. I never heard you. All right, I guess I lost it.
0, 0.
Oh, 0, 0. Oh. That's 3. Come on. The others?
20, 0.
20, 0. 20 on the X, 0 on the Y. Anything else?
Sir, from right there, it's a 14, 16.
2015.
2015. Where did that 2015 come from? Where is the 2015? 20 on the X and 15 on the Y. That's like up here, you know. This is up here.
2016.
The 2015, I'm just correcting him. So the 2015 is right here, you know. Sorry, a bit further. It should be right here. I'm going to label this point X. So it would be right here. My bad. So that's 2015. That's not in our feasibility region for the young lad that had spoken, right? And remember, when you're writing the coordinates, you want to have the brackets as well. So don't just write 15, 16. Yes, Josiah, go ahead, quickly.
15 on the X and 15 on the Y.
No, we're straying from the point now. It can't be 15 on the X and 15 on the Y. Did I not see that point? Yeah, I never saw that point. So let's see, 0, 0, 0, 16, 14, 16, 20, 10, 20, 0. So I think Josiah would have said 15, 15. That's not actually a vertex, right? Remember, it's where two, what's called lines or line segments would actually meet. So those would be the coordinates of that value.
Sir,
So,
where the 14 going kind of off?
Repeat?
The 14, 16?
All right, the 14, 16. So it would be right here, right? In the blue line, the blue point, sorry, right there.
Okay, thank you.
All right. And just as a reminder for the persons who never saw the 14, 16, you would have gotten a pentagon, yes, not a hexagon. You can't say pentagon or hexagon. It's one thing or it's either one thing or the other thing is wrong in this one. So if you wanted to get the 14, you would have to subtract the difference between the 2 points that the line would be at, or I should say X values, which would be right here. You subtract 10 from 15. Sorry, 10 from 15, you get 5. And then you divide it by how many equal intervals you have from 10 to 5. So there are 5 intervals from 10 to 5. So this would therefore give you 10 from 15, which is 5, divided by 5. So each of these little smaller squares would be 1 unit. So you get 11 right here, 12 right here, 13 right here, and then finally 14, right? So that's a little trick that you can use. Well, not really a trick, but that's something that you can use in order for you to understand the graphs a bit better, likewise in physics. All right. So we want to calculate the maximum, the maximum wage. Now, can anybody remind me of the value or the equation, I should say, that speaks to the maximum wage? Well, it's on the screen, but yeah.
It's on the screen.
Yeah, it's because I couldn't see it because something was blocking me. So that's why I said, oh, it's on the screen. My bad. But good. So 3x added to 5y. So we need to find out what's the maximum wage. How can we find out the maximum wage? What should we be using? What can we use to find the maximum wage? We have the equation, but what do we?
The coordinates.
All right, which coordinates?
So, sir, you would use the vertices that intersect on the actual graph, right? And you would insert those coordinates into the actual equation and test them to get the maximum value.
See which one is higher. So you want to look at the feasibility region. This is why we highlighted the vertices, right? So I want you to do that quickly. Khadija, you have something else you want to say? Go ahead, you can speak.
No, sir, it's fine.
All right, cool. Oh, you were talking. Oh, my bad. All right, so you are going to work out that for me to see what, in this instance right now, which are these coordinates of these vertices, vertices of this pentagon gives you the maximum, right? And remember, we actually want to find out, besides finding the maximum wage, what else do we want to find? Can anybody highlight that to me? All right, remind me, what else do we want to find? Besides the maximum wage, what are we actually finding? No one? No one? All right, let's see. So I want you to tell me what you got when you use coordinate 0, 0. 0 on the X, 0 on the Y. You tell me how much you got.
So, sir, we're supposed to test them individually. I thought we should just test. And
you're going to do them individually. Not because it's at the top, not because you think it's at the top, that means it will have the greatest value. You have to check them out individually, right? in this scenario. In other scenarios, you don't have to do that. But for this one right now, I'm directing you to do that one. All right. So using 0, 0, what do you guys get? Using x as 0, y as 0, what do you get? Hello.
There is 0.
Okay, 0.
0, 0, 0.
All right, cool. The next coordinate I want you all to use is 0, 0, 16. Tell me what you get. So when x is 0, y is 16, what do you get?
So I got $80.
All right. So you put your $80, remember your units. So when you plug that in or substitute that in, you got $80. And the other one, since it's on the screen, 14 and the 16. 14, 16, sorry. 14 on the x, 16 on the y, we would have got 122, right? All right, the next one I want you all to do is the 20 on the x and 10 on the y. Tell me what you got for that one.
110.
I got 110.
All right.
110.
All right. And the last one, 20 on the x and 0 on the y.
60, sir.
All right, good.
60.
All right. We all got those points, right? So what is our highest, maximum wage? What coordinates our vertex gives us our maximum wage?
14 and 16 gives maximum wage.
All right. So what does that 14 and 16 represent? In other words, it's our what? I would have said the aim of the optimization problems is to find the dash and using a number or several constraints. What is that dash that I just referred to? Let's see if anyone was listening or paying attention or looking at the screen. The optimal, the aim of the optimization. All right, solution of what? Solution of what? Solution what? Solution what?
Of the constraints.
All right, good. He said it already. He or she, I think it's a boy. All right, so it's an optimal solution, right? So that 14, 16 represents the optimal solution. So how many kilograms of apples should I pick? And what is the number of kilograms of pears should I pick? What would that be? So you have the optimal solution. And remember, based on the question down here, it says help John to determine how many kilograms of apples and pears he needs to pick to earn the maximum wage. You all know the maximum wage, which is $122. Now, I want you to tell me how many are the number of kilograms of apples John would pick.
42 kilograms.
42? You sure? So what does this x-axis represent? Does it represent apples or pears?
Apple.
Apples. And how much did you get for your x-axis value when you got the optimal solution or the maximum wage? How much did you get? What was your x value for the optimal solution?
42.
No. The optimal solution for your x value, the x-axis, 14. But 14 what? It's not just 14 apples. Remember, it's not 14 apples.
14 kilograms.
Is different from 14 kilograms. Yes. So John would need to pick how much? 14 kilograms of apples. And as Lanzo would have said, 16 kilograms of pears, right? To earn the maximum wage. All right? Is everybody seeing that? So whatever your function is, in other words, your maximum wage, that value, yes. So that value is going to give you the amount of kilograms or number of kilograms that you need. All right. So let's go on to something very, very nice, I would say. The CSEC past paper questions. All right. So let's start with January 2019. So Mr. Thomas makes X bottles of juice and Y cakes each day to supply his customers. He makes at least 20 bottles of juice and no more than 15 cakes each day. Now, they want you to make some inequalities out of that. So what would our inequalities be? So you want to say at least, and remember you have a graph paper to plot this one as well. So at least 20 bottles. How would I represent at least 20 bottles of juice? What would my inequality look like? Anyone? At least 20 bottles of juice. What would my inequality look like? All right, X is greater than or equal to 20. All right, one person. Any other comments?
You can type if you agree or disagree with Maya in the chat.
All right, Davis would have said something different. All right. All right, cool. Josiah, you can go ahead, speak. I agree with Maya, okay. All right.
Yes, sir. X is greater than or equal to 20.
All right, and she said it best. So X is greater than or equal to 20. All right, why are some persons saying it's less than or equal to? At least 20 bottles. I have at least $100 on me. That means I have $100 or more. All right. Kenny and Keno, why are you guys stating that? You're writing 20 less than 15. That's not what is underlined. It says at least 20 bottles of juice. Remember that X represents the number of bottles of juice, right? So you can't just use numbers 20 and the 15, okay? All right, Keno and Kenito. So it would give you X is greater than or equal to 20. What about the other one? What is the other worded statement that I can translate to an inequality or an algebraic statement? What is the phrase? I want the phrase, not the answer. So what would the phrase be? Hello. What phrase should I underline?
No more about.
All right, no more than what?
15 cakes.
15.
No more than 15.
More than 50 cakes. All right, what would that inequality look like?
Sir, Y equal to less
Y
than or equal to 15.
Oh, okay, less
What?
than or equal to 15. Does anybody disagree? Agree? Likewise with what Moira would have said.
So you disagree? Y is less than or equal to 15.
All right, good. So I've gotten at least 4 responses. So Y is less than or equal to 15. All right? Is everybody on the same page? Is there anybody lost to that one?
No, sir.
No,
sir. No.
Again, you want to take it piece by piece, decipher it, and look in the sentence or look at the sentence and see what inequality or which inequality comes out, right?
Excuse me, sir.
Yes, go ahead.
So why is it that for X you have less than and equal to 20?
Less than or
Is
equal to
it-
20? That's a sign? You sure?
is-
What sign is this?
Reading from left to right.
Oh, greater than and equal to. Okay.
All right. Oh, so you're reading it incorrectly then.
Can you explain that, please?
All right. So we're saying that for an inequality, right?
Yes.
We generally say, or we have terms that we use to represent greater than or equal to or less than or equal to, right? When somebody says, well, based on a statement, it says at least 20 bottles. That means it's either you have 20 bottles or more, right? So that's all that is actually saying. So the number of bottles of juice, which is represented by the variable X, is going to be greater than or equal to. If it's less than, that means it's saying that it's no more than, right? So you want to understand some of these key phrases or words that can be used to represent some of these inequalities, right? So it's really about the wording. You want to pay close attention to the wording and even visualize it if you must. Visualize it and see. All right, I have at least 20 bottles. That means 19 bottles. Think about it, right? You want to visualize it. Most of the things you want to visualize in your head. If you don't want to visualize it, write it on a piece of paper and you can take it from there, right? So it all comes down to our comprehension skills and reasoning skills. So that's something that you want to think about and try to improve on it. Likewise with everyone right here, right? Does that answer your question a bit?
A bit.
All right. A bit is better than none. All right.
Because, well, for at least it will show that
Any one of my colleagues have any other input to like ease her mind?
So I'll just add in,
yeah.
I kind of sent Kino a private message, but I'll just say it for the benefit of others, because not everybody likes to speak out. Kino's asking, sir, at least could mean that it could be less also, and it's probably because least and less they're thinking of least being related to less, but at least, so if you said to somebody, I have to get, I need at least 5 bills for buy something. If you need at least 5 bills, if you have 400, it can't be. If you have 400, which is less than 500, you can't buy what you need. So if I say at least, I have to have that value or more. So although least kind of remind you of less, you don't use less than. It must be the value or more. So if I want at least a certain amount of money to do something, I can't have less, because that means I can't buy the thing. Does that help, you know?
Okay.
And the young lady that's speaking.
Okay.
All right.
All
Good.
right.
I'm glad it's clear. Oh, at least, don't make the least and the less confuse you. At least means you can't go. You have to have that or more. No more than mean that I can have that or less.
Yes.
Can't pass it.
So my suggestion would be, if you see words like that, put them in an everyday situation that you would use, as Ms. Harris was saying, for example, money. So suppose you were speaking about money and you say, whatever is the phrase, at least, I need at least $500. What does that mean for you? What are you trying to say to yourself? So use the term in an everyday sense. We call that solving a simpler problem, something that you know already, and then see how you can fit back the phrase into the question to understand what it means. And remember that this inequality symbol, the wider part always opens to the amount that you're saying is more. And the narrower part, the end of the V, the narrow part also points to the part that you think that should be less. So you are using those two understanding, which is your real life use of your terms, and also understanding the symbol itself. That's it for me.
Thank you.
Okay. All right, good. So let's look at the second part of this question. So each day, Mr. Thomas uses no more than $163 to make the bottles of juice and the cakes. So the cost to make a bottle of juice is $3.50, while the cost to make a cake is $5.25. Now, they want us to use an inequality in order to represent this information. So again, you want to decipher each of these sentences to see if they're actually related in a sense, and let's see what inequality we get. So let us see what inequality everyone will produce for this one. So again, each day Mr. Thomas uses no more than $163 to make the bottles of juice and the cakes. The cost to make a bottle of juice is $3.50, while the cost to make a cake is $5.25. They want you to represent this information that was said above as an inequality. So I'm going to give you all some time, and then we'll see what happens thereafter. So you can, when you're ready, you can raise your hand and we'll address you shortly, or you can type in the chat and we'll read it out as is. So Maya is saying 3.50x plus that. Okay. All right. So I got 2 responses so far. Maya and I'll say Mrs. Linear Programming, Mackenzie, because she loves linear programming that much. All right. By the way, is it that your exes are Khadija Mackenzie and Zavian? Sorry if I'm pronouncing it wrong. Is it that your exes are actually far away from the 3.5 or is it close to the 3.5?
No, sir, it's close. It's just the title.
All right, 3 responses. Okay. Everybody's, I think 3 persons are saying the same thing. I need 1 more to break the ice. So when it means no more than $163, what sign should I be, what inequality symbol or sign should I be using? When it says no more than $163, what sign or inequality? Okay, good. So that's one thing to note. And what is the cost? Okay, yes, good. And what is the cost to make a bottle of juice? What variable is represented by the bottle of juice? That's going to be what? What variable? X, Y, X. So you have the $3.50 multiplied by the X, right? The variable X. Added to, because you want to find out what is the cost of making these 2 things, as what the question would have said in the first part. And you have the $5.25 being represented by, or being multiplied by the variable y, as that represents the number of cakes, and so on and so forth. So we get this little inequality. So we basically have 3 inequalities so far, right? Everybody's seen that? All right. Everybody's on the same page?
Yes, sir.
Was that? All right.
Yes, sir.
All right, let's move. So it says show that. So they know that the answer, it is not possible, but it's for you to actually show them. And how can you show somebody something? By giving them an example. In this case, they gave you something. So let's see how can we use it. Yeah. Understood. So we want to show that on any given day, it is not possible for Mr. Thomas to make 50 bottles of juice and 12 cakes. What will you be using? Or you want me to go back? What will you be using in order to find out that on a given day, it is not possible for this man to make 50 bottles of juice and 12 cakes? Is that good enough for you, Kenito?
Yes, sir.
All right. So we're on to this. So what are we going to use? What are we going to use to find this answer or solution? What inequality are we going to use? What have we done so far? So on a given day, they want you to show that you can't make 50 bottles of juice and you can't make 12. So as Kino would have said, your X value is 50. That represents, X represents the number of bottles of juice, which is 50, and Y is represented by 12. All right, and I see some lovely little good stuff, Wallace. That's nice. Anybody else? Well, I guess everybody's doing the calculations. So I'll give at least 15 more seconds. All right. So again, we're using the inequality 3.50x plus or added to. All right. So everybody, 2 persons so far on the right page. So is 238, is that less than or equal to 163? Yes, no, yes, no. 238, is it less than or equal to 163? All right, it's more than. So is it possible for him to make that 50 bottles of juice and 12 cakes. All right, so everybody's on the right track so far. So you'd have used that 50 for the X and the Y as 12 and substitute those values in to your, not necessarily inequality, but you want to show that you get $238. And obviously that is way greater than $163. So again, is this possible? No, it is not. Right? Is everybody seeing that? So
Yes,
this
sir.
is not possible because on a given day, he can't exceeds 163. And that's another word to use, by the way. If you see the word exceeds, what does exceeds mean as an inequality symbol? What should you write? The word exceed. When you see that, what comes up?
Should not exceed.
Well, yes. Did he say should not? My chat thing is blocking it. Sorry, my bad. I should say should not exceed. My bad.
If it should not exceed, should it go over, Shayera?
Should it go over the 163 or should it be less than the 163? Less than or equal to, sorry.
Right, so if it exceeds, it goes over. So that would be greater than or equal to. But if they say it should not exceed, it has to be less than or equal to. So just be careful of be aware of what your wording is saying. And quickly on that, sir, so it would mean then, students, you would not do your substitution with the inequality sign involved. You would just do a substitution in the expression part. You wouldn't use it because at the end, you're going to end up with a nonsense statement that 238 is less than or equal to 163. So as sir has shown on the slide, you just do your straight substitution into the expression, and then you make your statement that it is greater than the, it doesn't satisfy your constraint. So I saw a couple persons using the inequality in the calculation. Just bear in mind, you don't do that. You just do the straight substitution and then show that it is more or it is less based on what they asked you to do.
All right.
That's it from me, sir. Sorry.
Yeah, man, that's fine. All right. So it would not be possible to get to that, have the make 50 bottles of juice and 12 cakes, as you would have seen that it's 238. And it's practically way more than the 163 that was given in the question. Now, is that okay for everyone? I will be asking for at least, no, let me not use at least, no more than 15 minutes of your time that passes 2 o'clock, all right? Is that fine with everyone?
Yes, sir.
All right, cool. And you can say it's like regular class, if you want to call it that, because you've been here since 9. But you get a little break, but yeah. All right, cool. Thanks much. Thanks, everyone. So let's look at this May 2021 paper. Well, question. It says Mary buys 2 types of mobile phones. You have the B Flow and you have the C Flex from a company to retail. I mean, she's going to sell it back. That's what that means. So one B Flow mobile phone costs $60, while one C Flex costs $80. Now, she buys X number of B Flow phones. So the X represents the number of B Flow phones that she can buy. Then Y is being represented by the number of C Flex phones that she can buy. So they gave us our variables. It's for us to actually assign them to this particular question or phrase. Now it says, the first part, Mary must not spend more than $1,200. We want to write an inequality to represent that information. So let's see what everybody gets. 1,200. You should not spend more than 1,200. All right. All right. Well, Moya is fast on the block. It's like you did this question already. All right. 60x added to 80y less than or equal to 1,200. Does anybody agree with her or do we disagree? 60x added to 80y is less than or equal to 1,200. Go ahead. Do we agree or disagree with what Moya had gotten?
So.
Yeah.
60x plus 81 is equal to 1,200.
Repeat the inequality sign that you use. Could you repeat it?
Less than or equal to
Oh,
1,200.
less than or equal to 1,200. All right, good. I guess everybody's on the same page. Fantastic. So the $60 that represents the cost for one B-Flow mobile phone, right? So you're multiplying that 60 by the variable X because X represents the number of B-Flow phones that you can buy or ascertain. Likewise with the 80 and the 80, which represents $80, which represents the cost for one C-Flex mobile phone. So we use those values in order to ascertain this inequality. So this is the inequality that we get. So we have 60x added to 80y less than or equal to 1,200. I won't say it yet. Yeah, I'm not going to say that right now. All right, cool. Part 2. The number of B-Flow phones must be greater than or equal to the number of C-Flex phones. You want to write down an equation in X and Y to represent this information. So go ahead. Go ahead. Let me see the chat blazing.
While the writing, sir, are those in the chat blazing just yet?
I think it's just starting. X is greater than or equal to Y. Anybody has something different, something similar? All right, one person would have said something. So let's see if the others have anything else to say.
Admit it. X is greater than or equal to Y. I agree with.
All right, good. All right, yeah, they're flowing in right now. So, yeah, all right, cool. X is greater than or equal to Y. All right, that shows a little bit of understanding. But let's see what happens when we're gonna pop this on the grid. All right, let's see what happens. All right, so it's X is greater than or equal to Y. And obviously we can write this another way. How could we write this, by the way? How else could we write this inequality? How else could we write this inequality? Even though it's not
Y is greater than equal to
X.
All right. Oh, sorry.
Other way, sir.
Yeah, my bad. I forgot that it was actually there. All right, cool, nice. All right, let's continue. Now we want to represent the two inequalities that we have on. We want to represent the two inequalities that we have on the grid, and we want to label R as a region which satisfies both inequalities, right? So if you notice, we have a graph paper that is given, right? So at times you might see a graph paper, as in it's already labeled X and Y, and I have the values. Now you notice, well, what do you notice? My bad. What do you notice on the graph? What do you notice on the graph that they gave you? Anyone? Graph that they gave you. Okay, let me look.
Sir, the graph is a bit too small.
Yeah, it's small. Is it really small? Remember, I said we could have fit a million things on this, to be honest. It depends on our scale. So they give you this. So how can you manipulate this now to plot this 60x plus 80y less than or equal to 1,200? I mean, the x greater than or equal to y is simply to plot.
Sir, you cannot plot the first. It has to be simplified.
Oh, you have simplified. So how are we simplifying?
Sir, you divide everything by 20.
All right, why are you dividing by 20? Might I ask?
Sir.
So,
No, divisible.
it's divisible by 20. What about those terms that we use in primary prep school? Those look at terminologies that we use. They come back to haunt us,
Sir, why would be 15?
All right. I haven't asked you for that yet still, but all right. Let's see if that actually is true when we're doing that part. So why are we actually dividing by 20? Both sides. Can anybody interject and tell me why?
Because it's the highest common factor.
Yes, those terms, those fancy terms. Yes, those terms are fancy. Highest common factor. So the highest common factor of 60x, 80y, and 1,200 is 20. 20 can go into all of those numbers. That's the highest number that can go into all of those three terms without leaving a remainder. So that's something that we use. Not because you think the graph isn't feasible, not necessarily feasible. It's small, doesn't mean it can't hold. What I mean by that, you simplify your thing. Just like how they simplified your graph and made it a bit smaller. We only simplified inequality for the ease of this calculation right now, right? So this is why they would give you this graph to see what you'll be doing. Most persons would actually might give up and say, but 1,200 are really depend on this. What am I gonna do? So this is what we do. In order to ease the calculation, we simplify. So when we simplify, two persons would have said that we get, what's this? 3x added to 4y. Is that equal to? All right, okay. Less than or equal to 60. All right. So let's go. So we would have divided through by 20. All right. And we'd have gotten 3x added to 4y less than or equal to 60. Is that any better for all of us? All right, and silence is a good thing. Okay, so we have that equation, well, inequality. Now, what would I need in order to plot an equation for this line? If I had 3x plus 4y equal to 60, what would I need in order to plot the line of 3x added to 4y is equal to 60? What would I need? You need a what? What do you need? Somebody just said x. What in x do we need? What do we need in order to plot a line?
Sir, the coordinates.
All right, what are the coordinates? What coordinates should we be using?
0, 15, and 20, 0.
All right, why did you use those? Why are those so popular to use? Why are we using that? Why are we using the 0 on the x and the 15 on the y, the 20 on the x and 0 on the y? Why are we using those?
Sir, because I work it out.
Oh, you work it out. You just use random numbers and get to the
Yeah.
answer.
How did you arrive at that? Why did you use them?
What are the words that
Well, this is because it's used as a reference point.
But what is that reference point called if you want to use that? Well, the line 3x plus 4 is equal to 6 is a reference point, but why are we using the coordinates of 0, 15, and 20, 0? All right, so somebody says it cuts through each other causes, well, sorry, those lines cut through each other causing a point. No, not quite. I thought you were saying something else when I saw the cut.
So how did you arrive at the 0, 15, and the, what's the other one again? 20, 0. How did you arrive at those? What were you calculating when you arrived at those values?
What are the terms that we were using earlier when you were trying to, yeah?
Sir, we can use the numbers from like the 3x going to the 60. We can use the 3x divided by 60. And that's how we have our point.
No.
All right, let me ask another question. Where exactly is the point 0, 15? Where do you identify that point? Where is it? Where is 0, 15 on your graph? Where would that point lie on your graph? 0, 15. Okay, David is saying on the y-axis. All right. And the point 20, 0, where would that one be?
On the x-axis.
Okay, so what are those 2 points that you've just identified? What's the term we've been using since morning? We have identified what? I forgot to play hangman. Should I give you a vowel?
No, sir, no, sir. No.
No, not coordinates, Fellaini. I don't show you pronounce the name. Yes, you've identified coordinates, but what these points, there are special names for these points. What are the names for those points?
Ordered there.
Which one?
Ordered pair.
No,
intercepts. Thank you, Lavery.
And
we have
Lonzo.
The y-intercept and the x-intercept. Thank you, Lavery.
So which one is the y-intercept, by the way? Which coordinate gives you the y-intercept?
0, 15.
Okay, and the other one would be the x. All right, so the intercepts are what we use in order to get to those ease of access for our line. So remember that we need 2 points in order to draw a line, all right? So this is what's going to be in the table. So when x is 0, y is 15. Work that out. When x is, we need to find the value of x. Y is equal to 0. So we substitute the value of y into that equation. Notice there's no inequality. It's an equation because we're using that line as a reference line in order to shade our region. Now, you would have already gotten to this point where you would have gotten the 3x added to 4y, the line. Now you need to actually show where it would be shaded. Now my question is, would it be shaded above or below? So if I had the line, so using the coordinates, 0, 15, 20, 0, where would that go? Where would I shade? So I'm gonna draw that line for you all. So that's one coordinate, 0, 15, and 20, 0, the other coordinates. And I will connect those 2 lines, 2 points together. So I will have 3x added to 4y is equal to 60 on this line, on that line in blue. So where should I shade? Lanzo had said below.
Below.
All right. Is everybody agreeing that I should shade below? Is everybody agreeing? All right, good. So we can use testing values as what we did right here with the 10 and the 5. And we got below. Now, what about the other one? The other, what do you call it? Inequality. That x is greater than or equal to y. So this is one of them. So what about this other one? The second inequality, x is greater than or equal to y. Where should I draw my line? What are the coordinates that I could use to draw this line? Is there something in specific or in particular that I can use to get to this line of x equal to y, and thereafter I will shade the region that satisfies the inequality of x is greater than or equal to y? What should I do? So again, you're using a line as a reference. So in essence, you're gonna have x is equal to y. Where should I have my coordinates, or where should I draw the line x equal to y? Where should I draw it? Is there anywhere in particular? Should I just draw a random line? What do I use to get to this line of x equal y? X equal.
Draw it from the origin.
All right, you draw it from the origin. Good. So when x is 0, y is 0, so on and so forth. All right. So that's our thing. So where do we shade now to represent the inequality? So this is what we want to do. We want to shade. Where do we shade? Do we shade above the line x equal y, or below the line x equal y as our reference point? Go ahead. Below or above? Do we shade above the reference
You
of x
shade
equal y or above? Below or above to show that it's x is less than or equal to y?
below.
All right. Does anybody agree, disagree? Remember,
You
you can.
shade below.
All
You
right,
shade
below.
below.
2 persons.
Below.
All right, good. Everybody's saying below. And you can test your points and so on and so forth. Now, this said we wanted to represent the 2 inequalities on the grid, which we just did by shading it in blue and yellow respectively. Now they want us to label the region which satisfies both inequalities. What section should I shade? I'm gonna just put 1 right here, 2 right here, and 3. Which region should I shade?
2.
2. Why do I shade 2?
Sir, because I already said what inequalities mean.
All right, so that is, and I label that as my R, right? So this is where they all meet. So if you don't understand, I'm gonna shade this in blue, and the part that I'm shading in blue is being represented by 3x, inequality 3x added to 4y is less than or equal to 60. Now the other part that I'm shading in red is indicating the inequality x is greater than or equal to y. And where do you see all of the 2 colors being overlapping each other? You see it at the point that I would have labeled 2, right? So that is something that you can use to identify the feasibility region when you're ready. All right? Is everybody good with that?
Sorry, sir, quick one. I might have missed you saying it, but just to remind students, they might be wondering, so how come I'm going below and I seeing a greater than symbol? Remember, we can also say this is that y is less than x. And usually when we're identifying our region and we're having y as a subject of the formula, in this case, y is less than x, so I have to be thinking about below the line. Just thought I'd jump in with that one. Hope that helps.
All right, thanks. All right, so this would have been our part 3 by labeling the part R which satisfy all of the inequality. Let me just get rid of this writing. And let's continue. I believe it's 1 more. So that would have been our region that we'd label R, and we get our 2 or 3 marks for that question. Now the 4th question. Now, this is asking us to determine the total number of mobile phones, which is represented by X added to Y. So they're asking you, what, according to the graph, what is the largest possible value of X added to Y? Now, what are some of the things that we need to consider when we are going to satisfy this X plus Y to find the total number of mobile phones? What are some of the things that we must consider? Are there any things that we need to consider? Should I just use a random point? Should I say, okay, I need 10 mobile phones. I need 20 of this C-Flex phones. Do I just use a random number? What are the things that I should consider? The optimal solution. Okay, fantastic. You're using the word. All right, so what does the R represent again? What term do we use to represent the value? Well, the thing that's called R. What do we normally use?
Sir, what you said?
Oh, McCarthy would have said optimal solution we could use are things to consider. But I'm asking, what is the value of R called? What do we
The
call
region R? What's the region R called?
Feasibility region.
feasibility region? All right, feasibility region. So from that feasibility region, what's the shape? What shape is that normally called? Well, I never said it, but what are the things that we look at when we see the feasibility region?
The feasible solutions.
The feasible solutions, all right. What else?
Sir, that did have fun something.
At least you remember. All right. Anybody else? Oh, a triangle. But you're saying why is this actually a triangle? And McCarthy would have said the vertices. So you want to look at the vertices, right? The vertices of this polygon. What else are we looking at? So I'm going to label the vertices, which will be labeled again. But these are the vertices, so you know it's a triangle. So it must be 3 or more vertices. In other words, 3 or more. Well, it should be a polygon. The feasibility region should be a polygon which has 3 or more vertices. All right, so that's something to note as well. So other things to consider, there's one more thing that should be considered. The mobile phones, just like what we did earlier, I would have said it earlier, when we were doing the apples and the pears. What did we say about that? The apples and the pears, we got 5 inequalities. We got 2 extra inequalities. What did we speak about those 2 inequalities? Can anybody tell me? No? All right.
Sir, you can never have a negative amount of
Yes.
apples
And
or pears.
remember, good. Remember, this is mobile phones. So you don't have a negative mobile phone. And don't tell me, oh, when you tear the phone apart and all that. No, that's not actual negative. You still have the phone. Anyways, so X and Y must be whole numbers. And we have spoken about the coordinates of the vertices. It's a polygon and it should, it imitates a triangle. All right. So again, those are some things to consider. Now, still back to the question. Now, we are looking at the vertices, right? And we want to find the largest possible value of X added to Y. In other words, the B phones added to the C flex mobile phones. So we would have taken into consideration the vertices, right? So what are some of the vertices that we have based on this graph? Well, continue.
20, 0.
20, 0. What are the other vertices?
Yeah,
Wait, has 0, 0.
Oh, 0, 0.
Type 0, 0 in the chat.
Sarah, can I have decimal?
No.
They refer to the whole number.
Wait. Let me see. Which other one? Oh, that's the one that you're referring to. All right, let's see what you get still. But I'll show you a little trick in order to go around that. So if you have this coordinate of 0, 0, which is 0 on the X and 0 on the Y, when you add those 2 together, you'll get 0, right? Now, the other coordinate at the apex, some of you might think that you'll get the same number. So 8.5, that's fair, which is practically what it is to some extent, give or take. All right. So the other coordinate that you would have said, which is 20, 0, 20 on the X, 0 on the Y. When you add X plus Y, what do you get? When you add X plus Y, what do you get? Anyone?
20.
When you add X plus Y, how much do you get?
20.
All right, 20. So that gives you X plus Y is equal to 20 using this coordinate. For the coordinate over here, would it be, what would this be? When you add the X coordinate and the Y coordinate, in other words, when you add the X values and the Y values, sorry, what do you get? And is that less than something or greater than something? So I'm going to compare it to the 20. So whatever value you get, is it less than or greater than the 20?
Less than the 20.
All right. So at what point would your optimal or the largest possible value of X plus Y be? At what point?
20, 0.
All right, 20 on the X and 0 on the Y. So this would be X plus Y is 20, which is this over here. So you'd have 20 B flow phones or something of that nature, and the C flex phones for the Y. Y is the number of C flex phone, mobile phone. All right, so we have come to the end of today's session. Tomorrow, if you have any friends or if you are actually doing City and Guilds, we will have a session tomorrow starting at 9 o'clock to 12 o'clock. So if you have any friends that do City and Guilds, you can remind them to tune in using the same link, I would believe. Yes, the same link. So that is it for today, but we have the evaluation sheet to do, well, evaluation form to do. So I'm signing off, but I will send the evaluation form right now. So do not leave until you have completed that evaluation form, right? So thanks for coming, and